Hey everyone, and welcome. So, if you're building anything on AWS, you're dealing with data. And if you're dealing with data, you absolutely have to be thinking about encryption. That's where AWS Key Management Service, or KMS, comes into play. It is a truly fundamental service for cloud security, and I can guarantee it's a topic that will show up on your AWS certification exams. All right, let's dive in. So picture this. You're designing a big application. You've got data all over the place, S3 buckets, EBS volumes, RDS databases, and everything needs to be encrypted. We could be talking about managing thousands, maybe even millions of different encryption keys. So how do you generate them, store them, rotate them, and control who gets to use them, all without ever accidentally exposing the keys themselves? Well, that is the exact architectural puzzle that KMS was designed to solve.
You know, the easiest way to think about KMS is as a super secure, fully managed digital vault. It's a service that handles all the really heavy lifting of key management for you. You don't have to worry about setting up servers or patching hardware to keep your keys safe. You just talk to the KMS service to create and control the keys that lock down everything else.
Now, you might be wondering, what makes this vault so incredibly secure? Well, it all comes down to the hardware. The master keys you create in KMS are protected inside these special, dedicated devices called Hardware Security Modules, or HSMs. These are physical boxes that are validated against a super rigorous government standard called FIPS 140-3. And here's the most important thing to remember: the absolute core promise of KMS. Your master keys never leave these HSMs in a plain, usable form. You can't export them. That is the security guarantee.
Okay, so we've got our secure vault. Now let's talk about the assets that are actually inside it. The keys themselves. So it turns out, not all keys are created equal. You'd think a key is just a key, right? Well, not exactly. Depending on your use case, your security needs, and even your budget, you'll need to choose the right type. And for the exam, you better believe that understanding these differences is absolutely critical. The two main flavors you're going to deal with are customer managed keys, we'll call them CMKs, and AWS Managed Keys. This table lays out the trade-offs perfectly. With CMKs, you get total control. You write the key policy, you decide when to rotate them, you can delete them whenever you want. Of course, all that control comes with a monthly fee and charges for every time you use the key. On the other hand, you have AWS Managed Keys. These are created for you by services like S3 or EBS. AWS handles the whole lifecycle, like rotating them once a year, and there's no extra charge. You can see when they're used in your logs, but you can't manage them directly.
So the takeaway for any exam scenario is this. If the question asks about needing fine-grained control, a custom rotation policy, or the ability to share a key across accounts, you need a customer-managed key. If you just need to check that, yep, it's encrypted box with minimal fuss and cost, an AWS Managed Key is probably your answer. And beyond how they're managed, keys also differ in what they actually do. The most common type is a symmetric key. It's just one key, like a house key, used for both locking and unlocking your data. That's your standard AES 256. Then you have asymmetric key pairs. This is like having a mailbox with a mail slot. The public key is the slot anyone can use to put things in, but only you have the private key to open the box. And finally, HMAC keys. Just think of these as a way to create a unique, tamper-proof digital seal for your data to prove it hasn't been changed. Okay, let's get into the real magic of how KMS protects data at scale. It's a pattern called envelope encryption, and it's brilliant because it's both incredibly secure and really efficient. The idea behind it is actually pretty simple. You don't want to use your most powerful, most protected key, your root key, to encrypt huge files directly. It's slow, and every time you use it, you increase the risk of exposing it. So instead, you use that super strong root key for just one small job, to encrypt another, temporary key called a data key. Then, you use that data key to encrypt your actual data. And this is exactly how KMS puts their model into practice. Your KMS key is that powerful root key. It lives safely inside the secure vault, and remember, it never leaves. Its only job is to encrypt and decrypt these little data keys, which then go out and do the actual work of encrypting your files and objects right where they live. Let's just walk through the workflow. First, your app calls the KMS API and says, hey, I need a data key. KMS then generates one and sends you back two things: the key in plain text, ready to use, and a copy of that same key that's been encrypted by your main KMS key. You use the plain text key to encrypt your data. Then, and this is the most critical part, you immediately discard that plain text key. Get rid of it. You store your encrypted data right next to the encrypted version of the data key.
When you need to decrypt, you just send that encrypted data key back to KMS, it unlocks it for you, gives you the plaintext key back, and you can decrypt your data. So we've got a secure vault and a secure process. But who gets to knock on the vault's door? Who has the authority to ask for a key? Well, that's where policies come in. They are the security guards for your vault. Every single customer managed key in KMS must have a key policy. This isn't optional. Think of it as the ultimate law of the land for that specific key. If a user isn't allowed to do something in the key policy, they simply can't do it. It doesn't matter what any other IAM policy says. The key policy is the final word, period.
Now, this quote from the AWS docs helps clear up something that trips a lot of people up. For a user to get access, the permission has to be allowed in two places: the key policy and their IAM policy. So a really common pattern is to use the key policy to give permission to the whole AWS account. Now, that doesn't mean every user suddenly has access. What it means is you've now delegated the power to your account admins to use IAM policies to hand out those permissions to specific users and roles.
And a final tip that applies here and pretty much everywhere else on the AWS exam: always, always, always follow the principle of least privilege. Don't give a user KMS/star, which is permission to do everything, if all they really need to do is KMS/encrypt. Give them only the permissions they absolutely need to do their job and nothing more. Okay, to wrap this all up, let's look at just how deeply KMS is integrated across the entire AWS world. This really drives home why it's such a core, foundational service. I mean, just think about it. When you enable server-side encryption on an S3 bucket, you're using KMS. When you create an encrypted EBS volume for your EC2 instance, you're using KMS. Encrypting an RDS database? Yep, that's KMS under the hood. It's the centralized encryption backbone for dozens of AWS services, giving you one consistent way to protect your data. And this is a perfect illustration of the AWS shared responsibility model. AWS is responsible for the security of the cloud. They manage the HSMs, the physical security of the data centers, the entire KMS service itself. That's the vault. Your responsibility is security in the cloud. You define the key policies, you manage who has access, and you use those keys to protect your data. So, as you're studying for your certification, just remember this. With AWS KMS, your data is securely encrypted, sure, but the ultimate control stays with you. You hold the policies, you control the access, you hold the keys to the keys, and that is a very powerful position to be in.